Hi, welcome to Quantum Academy for Physics. In this lecture, I am going to explain about derived physical quantities, derived units and derived physical quantities. Units are of two types, we know that. One is fundamental units and the other is derived units. What are derived units? Derived units are a combination of fundamental units. Okay, we know that we have 7 fundamental units. We are combining them. We are combining these 7 fundamental quantities. We are combining 2 or more fundamental quantities or fundamental units to form derived units. For example, I am taking force. According to Newton's laws, what is force? Force is equals to mass into acceleration. Mass into acceleration. Here, what is acceleration? What is the definition of acceleration? Actually, it's a velocity, change of velocity with respect to time. Change of velocity with respect to time. And definition for velocity is, what is definition for velocity? Displacement by time. Okay, displacement is measured in terms of meters. Why? Because here we are measuring the length. What is displacement? Final point minus initial point by time t. Okay, velocity. Here I had written only the definition for velocity. Okay, and we left with time. In the denominator we left with the time. Okay, so what is velocity? Displacement per time. Displacement is nothing but final point minus initial point by time t. Here what we are measuring? Length. Length is measuring in between final point and initial point. So what is a fundamental quantity, fundamental unit for length? Meter, right? And for time, second. Okay, now you just write force formula, mass into acceleration. Okay, mass into acceleration. Mass is measured in terms of kilogram. Fundamental unit for mass is kilogram into what is acceleration? Velocity by time. What is velocity? Meter per second. And here one more quantity we have, time, second. Okay, into 1 by s. Now units for force is kg meter per second square. This can also be written as kg meter into s power minus 2. Okay, in the denominator we have second square in the denominator. If you bring this to the numerator, you can write it as s power minus 2. So units for force, SI units for force is kg meter per second square. I think it's not visible here. I'm writing here. Force units are kg meter per second square. Okay, here we are combining the base quantities, base units. Okay, kg is used for measuring mass and meter for measuring length and second for measuring time. Here we are combining mass, length and time. That means a combination of these 3 physical quantities is known as derived physical quantities. 2 or more, we are combining 2 or more physical quantities. Okay, these are known as derived physical quantities. And the units which are used for measuring these physical quantities are combined together is known as derived units. Here we are combining. Here kg meter per second square is combined together to derive a formula for force. These are about derived units. I will give you a few more derived units for derived physical quantities. Just pause the video and copy all this, so that while revising for your exam, it will be easy for you to understand. So I'm going to explain in a tabular form for easy understanding purpose. I'm writing here the physical quantity as usual, same as fundamental physical quantities. Here derived physical quantity, derived physical quantity in this column, okay. And here I'm writing the SI unit, SI name of the unit. Here I am using International System of Units, okay. Here I am writing the symbol for representing this name of the unit, okay. Area, coming to, I am explaining about area. Area is nothing but a square meter. It's a square meter, and the symbol is m power minus 2, okay. Meter is a measurement for length, it's a unit for length, and it's a square meter and a meter power 2, okay na. And volume is cubic meter, cube m power 3, m cube. And speed and velocity, units for speed and velocity are same, that is meter per second. You just revise all the definitions, okay. Otherwise I will try to explain the definitions of all these physical quantities in one lecture. I will try to make a video for these definitions of these physical quantities, okay. Speed is nothing but meter per second, velocity is also measured in terms of meter per second, distance per time, displacement per time, okay. Meter per second is nothing but by s, okay. This is this symbol is denoted for division, okay. And this also can be written as m into s power minus 1. There must be no gap here, there must be no gap in between these two symbols. And angular velocity, I will explain the rules for writing the units, SI units, in my next lecture. Angular velocity is a radian per second. What is radian? I will explain in the last. I will explain in the last of this video, at last minute of this video. And rad, symbol for radian is rad, R-A-D, by second s, or can also be written as rad into s power minus 1. And wave number, next one is wave number. Shall I erase this? I will erase this. You just copy by pausing the video. We know that we have 7 fundamental physical quantities. Including those 7 fundamental physical quantities, we had 2 more physical quantities, okay. I will explain about them at the last ending of this video I will explain about them. Okay, and one more is wave number. Wave number, you just go through these definitions. Okay, for learning about units, you have to know the definitions of these physical quantities, so that it will be easier for writing the name of the unit and the symbols. Without knowing the definition, you can't write this name of the unit and the symbols. Okay, you have to know the definitions. If you won't know, using these units, you can also derive. There will be few rules for writing name of these units. Okay, using the name of those units and dimensions. If you learn about the dimensions, using these dimensions also, you will be able to derive a definition for the physical quantities. After learning the dimensions, we will solve problems for deriving the formula for the physical quantities. Okay, no need to worry. Wave number per meter. This per is used for division, for representing division. Per meter is nothing but 1 by m, or can also be written as m power minus 1. And the other is current density. Current density, you just please adjust with my handwriting. Current density is measured in terms of ampere. So scientist name you have to write in small letters only. Ampere per meter. Ampere per meter. And the symbol, you have to represent the name of the scientist in capital letters. Capital A by meter, M per m, or capital A into m power minus 1. I will explain about the rules for writing this name of the units and the symbols. No need to worry. Okay, and one more is movement. Momentum. It is denoted with P actually. Okay, momentum. Momentum P equals to m into v. Okay, kilogram into meter per second. Okay, kilogram is symbol is kilogram for symbol for kilogram is kg, meter m, per second that is s power minus 1. So these are the few derived physical quantities and the name of the units for these physical quantities, and symbols which are used for representing the name of the units. Okay, in my next lecture I will explain about the rules whatever we have to follow for writing the name of the units and the symbols. Okay, bye.